All right, I think that we did it, guys. I think that we, I think we're on Facebook Live. And hi there, my name is Dr. Christina Johns. I am a pediatrician and a pediatric emergency physician. I am joined tonight by my usual Thursday night partner in crime, Dr. Elizabeth Murray, who is also a pediatrician and pediatric emergency physician. And we are really fortunate that we have Rob Swanda, who is with us, who is an mRNA. Hi, Steph. Hi, Gary. Okay, gotcha. I'm seeing you guys. So there's some comments here that we're going to see. Yay, we made it! Thank you guys for confirming that we actually made it, because I wanted to make sure that it was going to work. So here we are. Rob Swanda is an mRNA microbiologist who has had an interesting journey to get where he is as one of the three squares in our Hollywood squares. So that is hi, you guys. So I'm glad you guys are here together.
So fun fact, I got to, when I was, 17 or 18, got to sit in the audience for Hollywood Squares and watch a couple tapings of it, so you could see me on TV once when we were at, I guess, Hollywood Studios and Disney. So I don't know if anybody remembers that show anymore, but I definitely remember it.
See, look at that.
I might be saying, what is that show they're talking about? Wow.
That is awesome. Yay. And thank you to the people who made it from Instagram. I know that was tricky, right? So strong work there. I'm still going to have some tech issues tonight, without a doubt. So bear with me. But Rob, we're happy that you joined us. So thanks for coming in on the first tech try here. So
thank you both for having me over. It's really exciting.
Yay, so good. So, tell a little bit about you. I'm going to say, first of all, just really quickly. So I met Rob because I saw one. Hi, Alexis. I saw one of Rob's videos on the Twitter or something that was so fabulous. It was like, this is how an mRNA vaccine works. And it was like 2 minutes, totally broke, like his entire PhD broken down for me to understand, right? And so can you tell me a little bit tell us about your journey, about kind of how that all happened and about your background, so everybody knows kind of to level set where we are.
Yeah, sure. So I'm in my 5th year of my PhD here at Cornell. And most of my research has involved around this mRNA technology, designing mRNAs, how it can be used in the cell, how it's metabolized, degraded. And one of these projects actually is designing mRNAs for treatment of different forms of cancer. So I had a lot of background in actually making the mRNA, the delivery system that we're using. We also use LNPs, or lipid nanoparticles. People have probably heard that word thrown around a lot. So my parents began hearing about this mRNA vaccine in the news, and we're kind of hearing some of the propaganda, and they're not scientists, so they had asked me, like, you work on mRNA, right? So like, what is this actually about? Is this safe? Should we take it? What do you think? And so I said, okay, let me break this down. We did a quick little Zoom or FaceTime call, and I just was drawing on a piece of paper and showing it to them. And then at the end, they were like, whoa, we really understand this. Like, maybe we should get a PhD.
What a good son.
Too.
What a good son.
Yeah.
Thank you.
Right.
But also, I think it's important. So it shows that this mRNA is not new. People have gotten PhDs in it for a long time, right? It's not a new thing. It's just we're understanding, we're applying its normal functionality in a different way.
Yeah, and really, actually, some of the people have done their PhD on such a small little piece of this mRNA is what also I want people to understand, just how is it even entered into the cell, and the exact sequence to make sure a protein is made, because if you're off by just a little bit, it doesn't make anything. It's just degraded and it's gone, which I know you all have talked about on some of your other episodes. But just there's been a lot of precise research and education going into mRNA itself before it was even thought of being used in a vaccine. So that's definitely a really good, important thing to highlight. And so then after I explained it to them, they asked, oh, would you mind just putting this into a video? My mom, she cuts hair, so she has a lot of clients that will come in once in a while, and they know that I'm a scientist. So they ask, oh, what does he think? Does he think it's safe? Or does does he thinks that virus is spreading more or less? They're always asking all the, all these questions. So she's like, if you make this, then I can show them. And she's like, maybe it can be really quick because, they just want some information really fast. So, okay, like I'll draw this out on the whiteboard and we'll do it. And my friend who had helped record it, she said, well, why don't you just put it on like Twitter and Instagram? You might get some people who don't know the technology and they can understand it too. And I only had like 100 or 200 following. And then after like one day of it being up there, it exploded and is continuing to be viewed. So more and more
27,000 followers later, right?
Yeah.
Yeah.
It's awesome. And if any of you guys haven't seen the videos yet, I mean, I'm going to just do the shout out now to get it out of the way. You've got a YouTube channel, right? That is that what's the name of it? Can you share it?
It's under Rob Swanda. Yeah. Actually, I think one of my friends is on here, Magenta. She's a good friend of mine, and maybe she can post the link. So she can, I'll have her post it in the comments if she doesn't mind.
Yeah, they're fabulous. They're totally great. And with that, just to kind of get right to the content here of what we wanted to talk about, is that a little bit of the differences between, what does it mean, a viral vector versus an mRNA? How are those different? What's the sort of the bottom line of what people really need to know about those?
Right. So the similarities between them is that they're both going to make that spike protein, and then we're going to elicit the immunity to make antibodies against the spike protein, and then that will be the protection for us in case we see that virus in the future. So the downstream immunity effects are the same, but just the way we get there, kind of like taking two separate roads to get to the same destination. It's just a little bit different technology. So
and I think that's a really critical point, though. If we just touch on that a little bit, sorry to interrupt, but
no.
The end game is the same. It's not that we're having the body respond in a unique way or a different way. It's still doing the same thing that the vaccines have done all along. It's just a slicker way of getting the body to do it.
Yeah.
Yes, exactly. And almost like a faster way too, because in the past, using an attenuated or weakened form of the virus, or even a portion of like a viral protein, takes a long time in the lab to grow up the amount of virus, find the right strain that's going to be weak enough, and then administer that into a vaccine. So that also adds into the speed of how quick these were able to be made. And it's not like, avoiding any safety, safety was not was still being taken into account. We were just able to do things a little bit faster.
Yeah.
And so with the mRNA vaccines is you're basically getting the instructions in order to make the spike protein via the mRNA. So I like to always think like DNA provides the blueprints, where mRNA will provide the instructions, and then protein will provide the function. So that's the streamline.
You guys, this makes sense, right? Okay.
So that's like the streamline of how our genetic material flows. And the mRNA vaccines, of course, are going to come in at that RNA level. So they're providing our body with instructions. Our body knows it sees the mRNA. It looks like mRNA we make. So it's going to turn it into the spike protein. As soon as that spike protein is made, that's when our bodies elicit the immune response, because they know that that protein isn't supposed to be there. And then you have that immunity, the mRNA is degraded, and then it's gone.
Right.
So and then it's delivered via the lipid nanoparticle or the piece of fat, just because all of our cells are surrounded by a piece of fat, and that just helps for an easier entry of that instructions into our cells. So one thing that some ways that I like to explain it is, say you want to get like a recipe from your friend, or food from your friend, I'm sorry, and instead of them just coming and giving you the food, they're going to give you the recipe instead. So that's basically like what that mRNA vaccine is doing. And then the viral vector vaccine, kind of similar, but they're going to use DNA. So they're going to give the blueprints that will then your body will turn into instructions and then turn into protein. So a little bit more steps, which could be some relation to why the efficiency is just slightly less, but still very high for those viral vector vaccines. And they're using the adenovirus in order to deliver that. So they're not using the fat, they're using the adenovirus that typically would infect chimpanzees. and they've modified it so it can't make us sick, it can't replicate inside of our bodies. It's really just a shell to deliver the genetic material to make that spike protein. And then one of the other things that, because it is, giving DNA, and people were concerned with the mRNA integrating into our genome and causing mutations and all this stuff, now we should also address that the adenovirus, even though it's delivering DNA, it also can't do this. So, there's a variety of different viruses that we know that can integrate into our genome, but adenovirus is not one of them, and it's just not possible for that to happen. And one thing I like to also tell people is, like, if that was going to happen, I mean, we would be curing a lot of genetic mutation diseases if that was possible. So
exactly right.
Yeah.
So I'd say it's like a mugshot, right? It's like a photograph.
Yeah.
It's letting you recognize the person, but the person's not really there. So you know what they look like. So if you meet them in the future, you can say, hey, like the first time Christina and I met. Hey, I know you from Twitter.
Yes. Exactly.
And they just because it is, people hear that it's genetic material and they think, oh my gosh, it's getting into our genome, it's getting into the nucleus of the cell. Like there's all of that charge, right? We got to get rid of that energy. So how do you sort of help people get rid of that thought?
Right. Yeah. So I mean, I really try, at least in my videos, to just do things very quickly, like, within 2-3 minutes, because something that's very long, and like, I don't want it to come across like a lecture, because sometimes that can be quite boring, and just hitting some of the highest points of like you just mentioned, our DNA is in our nucleus, RNA is kept in the cytoplasm, it's always pushing out RNA. So like trying to go into the nucleus is like going to be like going up a waterfall. You're not really going to be able to get that RNA into that area. And also, like, the genetic material themselves are different. So like there's a reason that RNA is called RNA and DNA is called DNA. They don't really like mix together the same. So like just causing changes is, I mean, and it makes sense that people would be concerned because it is like new terminology. And I think that that's one of the reasons why like what you both are doing is so critical, and like seeing other people do it is it's explaining terms that people aren't familiar with and getting them used to those new terms that they're going to be seeing in the news, and sometimes the news gets that wrong. And just bringing to light like what those terms actually mean, and that's so important.
Yeah, no, that's for sure. I mean, I think we try to do a lot of that, breaking that down, because it's, for those of us who have a background in science, we hear these, like I could see, like, you're like cracking up hearing that, some of the things that people believe, because that science and like scientifically it seems probably so absurd, but that's what people, when you don't have that background, you don't know, right?
Right. It's
and pediatricians are really well positioned, I think, for this, because we're used to vaccine conversations anyways, but then, we're used to translating the information to another highly vested person involved in the patient's care, right? Parents obviously love their children tremendously, and so they understandably and rightfully so want to make sure that they have a full understanding. So, we explain to the best of the child's ability to understand, but then of course to the parent too. So
that's exactly,
that's why we're here.
That's why we're here. Exactly. So, okay, let's, and Alexis making a really good point that as a doctor, it is easy to forget. I mean, I'm not going to pretend like I have the level of understanding or can remember, probably half the stuff that Rob has already forgotten. So you're right. I'm like, what? And that's why we're so glad to have you here. There are a bunch of questions that, go ahead. You were going to say something.
Oh, I was just going to say, but also this is super critical, I think, not only for like us, but to highlight to other scientists and other physicians to be doing this type of work, because you do get kind of sucked into that bubble. And I've seen it here in, conferences, lectures, people they're only talking about with the jargon and the technical terms, and it goes over even other people's head. If I'm listening to a lecture that's maybe based more in like chemical biology or in like, protein like structure, like if someone isn't breaking it down as much, like I don't understand what's going on. So like that's always a good idea for anyone to be investing into like better communication skills to reach their audience.
Yeah, true story. No, true story. There are a bunch of questions that are over in the comments, and we'll get to those. But I want to talk a little bit, just so we can, again, sort of level set our science understanding. Talk about the point mutations and the variant, a little bit, the variant virus, so that we can understand a little bit. Again, we can talk about how the current vaccines that are out, how they're doing against the current variants, which is the bottom line is they're doing fine. I think that at the end of the day, they're doing fine. So not to worry about that. But can you explain again? And again, you've got a video on this one, so I would encourage everybody to go check your YouTube channel or your Instagram page because it's there. But in that, really brief snapshot, sort of explain a little bit about what is the point mutation that causes the virus, and we expect viruses to mutate.
Right. So
they all do. They all do.
Yeah.
So the mutations that people are concerned about are mutations that are occurring on that spike protein. Again, because that's what all these companies have been relying on, making the vaccines to create antibodies against the spike protein. So there have been mutations in other parts of the SARS-CoV-2 virus, but we just haven't been as concerned about them because that's really not what we're focusing on for this immunity in terms of vaccines. But some of the mutations that occur on the virus is occurring on the instructions when they make the spike protein. So you're going to always see like one letter followed by a series of numbers followed by another letter. So I explained that in one of my videos, and it's really just saying the first letter is the original amino acid at whatever position on the instructions, and then has been changed to another amino acid, which is the second letter that you see. So there's 20 different letters that are used. It can get confusing even for me to remember which one is which, but I do break that down in the video. And the mutations that they're concerned about, one coming from the UK, which is that N501Y, and that one there's been several published preprint papers coming out that show there's either no to slight, and then I've seen one that was as low as a threefold decrease of the antibodies binding to them. So try and take into account all the different papers coming out from different groups, because we want to be as well-rounded as possible with our information. But yeah, about a threefold decrease in the new variant binding to the antibody produced by the mRNA vaccine, which really doesn't mean that it's not working. It just means it's not working maybe as well, but it's still working, which is an important thing to note.
Dr. Fauci explained it kind of if you're at 1,000 and maybe we're down to 800, still really, really good. Not zero, but it's just not where it was.
But and Rob, can you say what that really means? So that if it goes from 6 times to 3 times, that means the strength of antibody binding, or what is that number?
So that the researchers were looking at the binding affinity of the so it just means it's not binding as much. So if it's not binding as much, it's not going to be able to neutralize, it's not going to be able to recruit that immune system to come and destroy this. But it doesn't mean it's not going to, just like Elizabeth said, you might need more antibodies in order to have that boost, but we already know that the vaccines give us more antibodies than natural immunity. So that's already a plus for us for the vaccines too.
Right.
And then there.
And I'm sorry to interrupt, but let's say that louder for the people in the back, right? Natural
immunity. Oh my God.
Natural that means
natural immunity. No.
Right. What that means is when you actually get COVID, right? So when you get COVID, you have developed natural immunity. That's some immunity. But what we know from science and from measuring that antibody response is that the immunity that you get from the vaccine is much stronger than what you get naturally, right?
Right.
Right.
Yep.
Right.
And then
you also don't get lung scarring and time in the ICU and muscle breakdown and maybe strokes and the hospital bills and time away from family and loss of jobs and all of that kind of stuff.
Right.
Natural has never meant good and healthy.
Yeah, but
exactly.
But I think that's important to really break that down for what does that mean? What is that? People hear oh, it was less effective. but what does that mean? And so that's why
Right.
I feel like we got to say that out loud. So,
and just like we were talking briefly last night during our test, is like, the natural immunity too is going to be more virus spreading, and these mutations occur when more virus spreads.
yeah,
So we're only, if we have more people getting infected, there's a higher chance that mutations are going to occur. And if we have more vaccines, like Elizabeth mentioned, then that chance of the mutations actually occurring goes down.
right.
So, it's a win-win for everybody.
Right. Well said. Yeah. Very, very well said. Okay. Let's dial into some of these questions just a little bit. Okay. People who have antibodies and then receive the vaccine after are having more intense side effects. Why? Elizabeth Murray, you dial into that one.
I guess, do we know that for a fact, or is that kind of a hypothesis? I haven't seen that officially published anywhere. And I guess, if that is true, it would kind of make sense, because your body's already a little bit primed. So you're already primed, the pump is primed, you're ready to go. So you're not doing that initial, hey, what's going on here? Let's respond. You're saying, oh, we know you. Let's go get them.
Right. Yeah, I think that's exactly it. If you have faced and come into contact with the virus before, you have some immunity already that you've developed. And so when you see it again, and see that spike protein element again from the vaccine, then your body is like, hey, I know you, and I don't like what you did, right? And then you have that immune response. So that makes sense. It is scientifically, it's plausible and certainly logical why people would have an enhanced reaction. Yeah. Okay, so let's get back into a couple of these. Have there been any studies of the vaccine not providing antibodies post-vaccine? I've been hearing a lot of people who are testing their antibodies after the vaccine and who don't have antibodies.
I think that's also very interesting to know that the antibody tests are still not like super reliable. So like take it with a grain of salt. And also, I don't know for sure how, like, what antibodies are those tests actually testing for. If they're not testing for specific antibodies against spike protein, then yeah, it's going to come up negative. Because there's 29 different proteins that are made in the cell or in the virus. So, you could have antibodies made against a variety of these different proteins if you had, an initial infection versus the actual vaccine, which you're only going to elicit that for that one protein.
Oh, that's a really good point to make too.
Yeah. The people that have been enrolled in the studies, I think they're checking them, for the specifics, just to kind of as a measure of how long immunity is present after the vaccine. I believe that's part of the longitudinal study set for the approved vaccines.
Yeah, for sure.
So in that situation, they know what to test for. So they're testing for the exact same thing. Exactly. Versus like my hospital just kind of did generic antibody testing early on to see where kind of things stood. Yeah. And I have no idea what they specifically tested for. Mine were negative, but that was months before I was vaccinated. Yeah.
Right. And I know Nicole's asking whether or not, if we want to share whether we've been vaccinated. I'm happy to report I have been. And I have my first dose, and my next one is coming up in a week. So yay. And
my husband and I are both about 3 weeks out from our second dose. So second dose of the Pfizer. Yeah.
Yep.
And I have not been vaccinated yet. I'm not in like the tier 1, but I did get, into the next, I think it's tier 1B, for being like a teacher or educator at university. But right now, at least in Ithaca, there is no appointments available. So like I do try to check it every day, but I can't find anything here. But I think that we can maybe like go to other areas or other counties, but I haven't looked into that.
Check the list on Mondays is the hot tip for upstate New York. Check on Mondays.
Good to know.
The supply gets there. That's what I'm hearing. It doesn't, the state has put in rules about you cannot make appointments for vaccine you have not yet received. So the problem is the state is distributing the vaccine in far fewer numbers than what we actually really need. And so these various distribution sites don't know what they're going to get sometimes until Sunday night. So then they can't release appointments until they have the vaccine in hand. So you got to keep checking.
Right.
but I will also report that apparently because of my video, both of my grandmas have appointments for the first week of March. So that made me happy.
Good.
Yeah.
Awesome.
That's
great.
A couple of other things that I want to just bring up, and I know that there are some other questions that are in the chat as well. And but one of the things that I wanted to comment about was the statement from the World Health Organization that I think has been largely misinterpreted about pregnant women getting the vaccine, and so. I just want to point out that some of you guys may have seen that there was a statement from the World Health Organization that the verbiage of it definitely indicated that it was the pregnant women shouldn't get the vaccine because it wasn't studied in pregnant women. And then note that the American College of OBGYN, the Society for Maternal Fetal Medicine, all came out right away with statements saying, look, we stand by what we said before, that there is no reason to withhold this vaccine from pregnant women. And I think that that's really important to say out loud right now, so that people,
especially in the high-risk population, so the healthcare field, teachers, the high-risk population, always have that conversation with your own provider, of course. But yes, and I think that kind of farther down, buried in the WHO statement, it says that too. We acknowledge that there might be some people where the risk is so great, and therefore, that's why I think ACOG and others had said, yes, the benefit for some far, far, far outweighs any risk, because we don't really know how there could be a risk.
Yeah, and getting COVID obviously is
big risk.
Pregnant women
Big risk.
So that is a big issue. And
And I think it also comes to the way that the vaccine is distributed too, in terms of giving mRNA versus not giving a live virus or bacteria. Which I think, some people get a little confused is if they see, oh, well, vaccines weren't, recommended for these vaccines if I was pregnant, but it's that was a different technology also.
Mm-hmm. Well said. Yeah, absolutely well said. So let's comment a little bit on length of immunity. So right now, what do we know about that? If you've gotten your vaccine, how long can you count on that immunity? Now, I've seen some data that was published, I think, in the New England Journal that indicate from healthcare workers that really looked at once you've got antibodies that at least 8 months. Right? Is that sounding?
I saw 8 months as well. Yeah.
Yeah. So that's the latest data. Can we speculate for a second and say, do we think that it is likely longer? Sure. Absolutely. We're speaking strictly to the science. That it's 8 months. So will we need booster shots? I think that's always the question that comes up, possibly. But
I remain prepared for a curveball to be thrown at us again by this virus that it'll be you get 3 years of immunity and then it turns off, or something just
something weird,
completely unlike anything else we've ever seen before, right? It'll wear off at some random time. And if you're 42, it wears off in 8 months. If you're 52, it wears off in 10 months. I don't know. I mean, I just feel like it'll do something weird. So more to follow on that.
Yeah, I think we'll know more about all of that stuff, about antibodies getting passed on to the fetus, about all of that kind of stuff. That's coming.
And the Pfizer and Moderna are monitoring their clinical trial patients, even up until at least post a year. And I think as we mentioned before, they're looking at the antibodies, and I haven't heard anything where any of them posted that they saw a decline in antibodies since their clinical trial started. So that's a good sign too, that it's at least lasting this long.
Right. Exactly right. All right. Let's shift back a little bit to the South African strain. Any thoughts about that? And the concern about, so what makes it more transmissible? What makes it cause more severe disease? Thoughts on that? How is that different? Or is it just really that letter and that number and that position and the spike protein? Is that really all it is?
So when you change, so again, when you have these mutations and you're switching one amino acid for another, and the amino acids come in a couple different flavors, and some are big, some are small, some are acidic, some are basic. So if you're changing in between amino acids and they're quite similar in their size, or their function, it might not change the actual protein that much. But if you change from a very small amino acid to something that's quite bigger, 3-4 times the size, then that's when it could begin to push the shape into something else. I think in my mutation video, I think I use like a Lego example. Like if you're, putting together a Lego set and you just grab a random piece, like maybe it will still fit, it'll be okay, but it might not look the same way that it's supposed to. And maybe, the car can still drive or can still operate, but maybe it can't. So like, that's kind of like what we're playing with these different amino acids. And with the South Africa one, they know right now, based on, I think it was only 2 different studies right now that I read about, there was like a 6 to 10-fold decrease again in that antibody to antigen binding affinity. So it means it's not working as well as it was for the non-mutated form, but it doesn't mean it's not working at all. So you just need, again, more antibodies in order to destroy this mutated form of the virus. But one thing I always like to mention too in the mutation video, just because there's a mutated form doesn't mean that the original form isn't also circulating. Right. So like, it's not like, oh, right, well, this one's here, the other one must be gone. We need to take into account that the other one could also still be around too.
Yeah, mutation has such a negative connotation that I think it just ups the ante just by using that word. It makes people feel like, oh, it's a mutation of something that's already bad. Oh my God, it's got to be really bad. But it doesn't. It doesn't.
Right. No, right. And sometimes the mutations actually are beneficial for us because, so right now, like one thing that I'm thinking is that, if the spike protein mutates too much, we know that the spike protein needs to use the ACE2 receptor to get inside of our cells, replicate, make us sick. But if, and that requires a tight binding in order for that to happen. But if it mutates to a different shape too much, then it's not going to be able to interact with that receptor. And, maybe it can't get into our cells. Maybe it can find a different way, but maybe it can't. So, that's one thing to think about. Like if the mutation occurs at such a drastic point, then it could actually be beneficial for us. Not to say that we should allow that to happen, but, just to give a positive to those mutations too.
Yeah, for sure. Also, LOL to your cat in the back there.
Oh my God! No, like, she's usually sleeping at this time, and now of course she's like so active. She wants to be the center of attention.
Super cracking me up and making me think constantly and red. And that is fabulous. So typically antibodies are passed through breast milk to the baby, and that is a good thing. That is usually how it goes. What we do know also is that there have been plenty of mothers of very young babies, newborns, who have had COVID and who had developed have had the infection, recovered, and then who have nursed their babies and have done fine. So we don't have any reason to believe that COVID, the infection itself, is transferred into breast milk. There's no evidence of that so far. So, so all in the same.
And the early studies were focusing on, you have a brand new mom who's actively sick with COVID. Let's make sure we mitigate spreading it to the baby, because it didn't look like there was going to be what's called vertical transmission, meaning the baby gets just by being in the mom's body. So I think that the numbers of vaccinated people who were pregnant and then breastfeeding are still really, really small. So as far as data on that, it's small. But the people who were sick, or the women who were sick and had babies, remember, you're not going to get antibodies to your COVID until the baby's 6 weeks or more old. So it's just kind of way down the road. So it can pretty quickly get to very small numbers when you think about all of the stuff that has to go into it. You need somebody who had it, who is still breastfeeding, who has antibodies and still breastfeeding, and all that kind of stuff. So it's going to take a little while, I think, to get robust data on it, but there's no reason to think that antibodies wouldn't get passed along.
Yep, exactly. Regeneron, if used early, thoughts on that?
I have no thoughts.
I think I actually really like Regeneron's technology. In terms of what Regeneron's antibodies do, it's designing synthetic antibodies that can be used to kind of mimic like a way that your own body could make antibodies. But Regenerons actually target the ACE2 receptor. So they block, it's a combination of 2 different antibodies, and they block the ACE2 receptor and don't allow or minimize the amount of virus that can get into your cells. So hopefully not allowing you to get too sick. And I mean, the clinical trials showed that people didn't go, into as severe COVID, which kind of makes sense. Is like, they still got infected, so they still had it, but it was minimizing the spread that it had in their bodies. The antibodies produced by Eli Lilly company actually do bind to the spike protein of SARS-CoV-2 and then kind of slow it down and serve as like a signal for your immune system to come and destroy it. And the antibody treatments too, I was seeing a lot of comments about these, is like they're not new either. Like we've been, using antibody treatments for a while also. One of the greatest examples is HER2 positive breast cancer. The Herceptin is used in order to block that receptor to limit the growth. So it's not something like to be afraid of, I guess. But one thing I have seen a little bit is it seems like the supply chain, just like with the vaccines for those antibody treatments, is not really getting out there and not getting to the locations that it needs to be.
Yeah, and there's some fairly specific criteria for whom it is most appropriate for, and that I think is important. That will likely probably expand as we, as the supply chain expands. As well. Hey, here's a great question. Can you still be a carrier after you've received the second dose of vaccine? If so, at what percentage? So that's right. That's the pivotal question, right?
The $1 million question, right?
Yeah.
Yep.
Yeah, and so I think that's what time is really going to tell, right? So after we are only now starting to get a sufficient number of people who have had the second dose of their vaccine, and we need to sort of now see what happens when they come in contact with SARS-CoV-2 and harbor the virus. Are they able to transmit it to other people? And that we know that the vaccine does a great job so they don't get sick. But the real question is, will they transmit it to somebody else? And do either of you guys have an early line on where that's leaning?
Well, I think Moderna is now following that, right? That's something that they're following their study patients on with asymptomatic testing. I think it was Mrna who was doing it to try to get a little bit more information on this question. Because again, we talked about this before, that when you have a study, you have to ask one question. You can't ask a million questions. So the life-saving question that had to be answered is, will any of these vaccines decrease severe disease and or death? And so that was a priority, right? Decreasing severe disease. So a nice benefit might be what we've seen with basically almost every other vaccine there is that it also decreases the ability to transmit the infection, but that technically just wasn't studied. So it is kind of now.
Yeah. Any other thoughts on that, Rob?
Not really too much. I haven't, like we said, there's not too much data out there, but it does make sense that, somebody could potentially have the virus and could spread it before their immune system has kicked in. It's not like the vaccine acts as like a bubble to protect the virus from, getting into you or, getting on you. So that's just something important to also think about, that, well, yes, you may be protected and you may be able to fight it off once it starts. If it starts replicating, that doesn't mean that the people around you, can do that also.
Which is sort of brings us to our public health PSA of the night, right? Why you still have to distance right now. We've still got to wear our masks. We've still got to do all of the things. And this is, I think, same answer. Can you still be a carrier and pass COVID if you had COVID and recovered, right? So kind of the same thing here. You may come into COVID, into contact again. You will not get sick, but that is the real question. So how likely do we think we're going to need booster shots, and how often? Thoughts on that?
Doing a lot of shoulder shrugging now. We're in the shoulder shrug questions.
These are all great questions.
Yeah, no, they're great questions, and I wish we had answers, but I think we still just don't know. Maybe.
Yeah, there just hasn't been enough time yet. I think that's the key thing, that these are all questions that are being asked and studied, but the this virus is so new that it just hasn't been enough time to say, everything is really encouraging right now that people who have antibodies, whether it is by natural immunity and certainly by the vaccine, are doing well and aren't having waning immunity after 6 months, right? Initially, because the study data was 3 months, we were like, 3 months. Now we're a lot more time has gone out. So now we're like, 6 months. And now it's on and so on and so forth. And so that is, I think, the important one. So, okay, here's one. So if you're, and we'll go for a couple, we're going over tonight. But Rob is so popular that we try not to hijack anybody's night, but here we'll go over for a couple more minutes. So if you are vaccinated, are you still at risk for possible long-term effects of the virus if you're exposed? Seeing that even asymptomatic may have lung damage, does the vaccine decrease this risk? That's a great question.
Well, I mean, that was the study question, right? Decreasing severe disease. And, I'm trying to think. I don't remember if there was, at least in the Pfizer one, I don't remember there being a specific comment. Well, no, they did. I mean, they tested people. So, I mean, I think that even the asymptomatic people were kind of monitored for severe disease. So
they definitely were.
I mean, I guess I haven't seen any data on true damage for asymptomatic people. I heard a lot of stories. So I'm not sure how rigorous all of those are.
Yeah, I think that we don't know. I think it is unlikely if you have less severe disease, it is unlikely that somehow long-term wise you are going to wind up with more severe disease. I think what we know from what we've seen so far is I think that's a fairly reasonable claim to make, that nothing is 100% in medicine.
Right.
And so I think
I think I would say though, there's 2 points that come to mind now, actually, in their pediatric specific. So I guess I would say big asterisks with the post-inflammatory MIS-C situation in kids. And then the other one is, we are screening for the moderate or the medium-ish severe disease the kids are still needing to have the cardiac screening done because of the concerns of potential there. So, obviously if something goes wrong with your heart, that could be very serious. And the concern is there might not be a ton of symptoms of that. And so that's why we're saying, kids who've had disease for, there's a bunch of criteria, a certain amount of days and a certain amount of severe symptoms and all of those types of things, they will then meet criteria to, maybe it's just have an EKG. It doesn't necessarily mean a full evaluation by a cardiologist, but some level of screening needs to be done.
Yeah. And that's a great point. When's J&J coming out? I'm waiting, man. Any other day, any day now, brother, right? That's the thing. And the return to, it's not just return to sports, it's return to any vigorous activity. I think that's an important thing for children. Next question. Do we have a better understanding of how children are or not transmitting the virus? School openings have been contentious, hard to make a well-informed choice with the data we have. So I think that we need to operate with some bunch of the data originally came out of South Korea that looked at especially the adolescent age group 12 to 18 did an equally transmitted that virus as successfely as adults. So
yay, teenagers were good at something. Yay.
Right. And there was less so in the younger than 12 age group. And that has stood to reason with what we have seen for spikes in schools and disease outbreak in schools so far. That's what the data tells us. With the accommodations and the structured environment of a classroom, especially 8th grade and below, that are not having sports and all of that kind of thing, that the data that disease transmission within schools is relatively low, which is why there has been a lot of media, a lot of call for opening of schools, at least in some format, and doing so in a stepwise fashion that is younger kids, elementary age first, for many reasons. We can get into all of the nuances, the psychological nuances, and social nuances as well. But starting with the younger age group because they've had more success. And of course, this is where I'm going to get out there and say, I think teachers need to be vaccinated before we do this. And so I fully support that. But I am all for, if we are able to have those accommodations in schools, and schools have a good plan, most school systems do, then I support schools opening with teachers having been vaccinated.
Right. I mean, but this is the caveat. We're not just saying send them all back like we did a year ago. We're saying send them back with the accommodations you're talking about, are masking, distancing, all of that kind of, good ventilation in the buildings, all of those types of things. And so I'm so quickly did I start to see on social media people saying, see, we can just open it up, schools are safe. And again, this desire to have dichotomies and all of the steps, I think is, it's safe or it's not.
Yeah.
No, all of this stuff in this mitigation phase is on a spectrum, right? That even if things are safe, it does not mean the risk is zero. It just means it's relatively low. I think we have more and more data coming out of various parts of the United States showing, like the Wisconsin data that the CDC was citing, where you have very high disease prevalence in the community, some places in Wisconsin that were studied up to 40%, and they had very low transmission within the school. So a huge community spread, but yet the kids were safe in the school. That's what our local data has shown us here when we were, 9% community transmission, which was horrifying to us, but not nearly as bad as 40. Again, really almost no in-school spread whatsoever. So again, it's not an all or nothing. There's a spectrum to this. Safe doesn't mean zero, but there's things we can do to make it really darn safe. It just, for the poor school districts, the overcrowded school districts, the older buildings, they're going to need more help.
Exactly right. Yep. Well said.
All right. I'm off my soapbox now. Thank you.
All right, guys, look, we've been going for 45 minutes. We promised that we will not go super late into the night, and I think we need to stop while Rob's cat is having behind him. Which has been great. What's the cat's name? We got to at least know.
So okay, you everyone's gonna really love this. The cat's name for short is Psy, but her full name is cyclohexamide, which is a protein synthesis inhibitor by binding to the mRNA and the ribosome and stopping a protein from being made. So, fun backstory on her name.
Right. You're really waving your science flag there, Rob.
Yeah.
That is awesome. That is great. Look, I cannot thank you enough for taking some time for us tonight to chat and explain. See what I mean, you guys? Rob does such a beautiful job breaking down, I think, really complex topics into bits and pieces that I think people who aren't in your same PhD program can really understand. And so I really commend you and thank you for that. And I hope that you will come and join us again and regularly as more science needs to get talked about.
Definitely.
Good. Well, I am so glad. Thanks to everybody who jumped on Facebook. Yeah, and I'm, look at that. This was very groovy that we made this work on this stream. So
I knew we could.
All right, where there's a will, there's a way. So thanks, guys. We'll see everybody next. Next week we'll let you know where we're going to be. Now you never know. We might be on the gram. We might be here.
I'm telling you, Snapchat. We're going to do 1 week all in Snapchat.
Oh God!
I think you could have like up to 8 people on Snapchat too. Video.
Oh my God! Oh wait, you can't actually do video calls on Snapchat? I was just joking, saying we were going to just send snaps back to each other, and then the whole thing flushes. In whatever, 24 hours.
All right.
No,
well,
we're not doing that.
Everybody have the best weekend ever, and lots of love to the Thursday night crew. Thank you guys so very much for jumping on. Special thanks to Elizabeth Murray and to Rob Swanda. Thanks. Woo woo. All right. Have a great week.
Thank you.
Bye.
Good night, everybody. Take care.